In the name of God, hello dear students. My name is Masood. I'm a physics teacher. We are in Ferkhwa's website to explain physics curriculum grade 11. So far we talked about some questions. We discussed some questions of chapter review. We discussed 24 questions, but right now we are going to discuss the rest of the questions. Let's get started. Question 25, an elevator is moving upward 1.2 meter per second when it experiences an acceleration of 0.31 meter per second squared downward over a distance of 0.75 meters. Right. So, uh, an elevator is moving upward uh, with this value. So this is the, actually, let me underline it. What's this? This is initial velocity of the elevator, 1.2 meter per second, when it experiences an acceleration of 0.3 downward. So the elevator is going up and the acceleration is downward. What does it mean? It means the elevator is slowing down, right? Because initial velocity is upward, is positive, acceleration is downward, is negative. So opposite signs of initial velocity and acceleration means slowing down. Maybe a passenger within the elevator, let's say, is uh, is gonna, for example, get off, right? Maybe we have this case: the person hits the button and he wants to get off, actually, from the elevator. That's why the velocity of the elevator actually is getting down, right? Over a distance of 0.75 meters. So we have delta x as well. We have initial velocity, acceleration, and delta x. What will its final velocity be? So what do we look for? We look for final velocity. Vf is unknown. Could you actually guess a rule that is appropriate for this case in terms of initial velocity, acceleration, and delta x? Right? So we don't have time interval. The only the only choice for this case is this equation. Only one equations among the kinematic equation does not include time interval. This is the equation. Vf squared is equal to Vi squared plus 2a delta x. Right. Vf squared is equal to 1.2 meters, 1.2 squared plus 2. Instead of acceleration, we have negative 0.331. Because it says downward, you have to mention this sign, multiplied by delta x, which is equal to 0.75 meters. So after calculation, it simplifies to the Vf squared is equal to 1.44 minus 0.47. I'm sure you know how to calculate it. Each term should be calculated separately. For example, you have to multiply 2 by negative 0.31, and after that you have to times it by 0.75, right? After that, actually, we have two numbers for each term. 1.2 squared becomes 1.44, and 0.47 is the answer of the second term. The last step is to subtract the 0.47, excuse me. You have to subtract the 0.47 from 1.44. And the answer is 0.97 under the square root, because I told you in quadratic equation, always in quadratic equation, in any quadratic equation, we have two actual answers, one positive and the other is negative. And actually taking the or choosing the sign is not arbitrary. You have to actually you have to write the question carefully to determine which sign works, right? Here, actually, positive sign is taken because it says uh, positive sign is taken actually because the elevator is going up. So this positive means the object is going up, and the case is slowing down. Maybe you say, teacher, how do you know the case is slowing down? Even without actually taking a look at the values, just actually think about the two things. It says the elevator is going up and the acceleration is going down. It doesn't need to any data, right? It doesn't need any data actually. But whenever you take a look at the data and the information within the question, you can actually take it out from the values. For example, 1.2 meter per second, this is the initial velocity. And we found what? We found 0.98 meter per second. So what does it mean? It means the object is slowing down. So mathematically and physically, information coincide with one another. Information match each other. Let's move on to question number 26. I'm going to discuss it with you. A ball is thrown vertically upward. A ball is thrown vertically upward. What happens to the ball's velocity while the ball is on the air? So you have to describe the motion of the ball whenever it's in air. Right. I forgot to bring a ball for you. And it's not just for ball, for any free fall object. You can describe the motion of any free fall object. For example, this marker, whenever you throw it up, what happens during the during its motion? What happens throughout its motion whenever, for example, you throw it up? What happens to the velocity? What happens to the acceleration? At the maximum altitude, what happens to the, for example, velocity and acceleration? Focus on velocity and acceleration. Actually, they are two important factors for describing the motion of any free fall object. Whether the free fall object is a ball or marker, it doesn't matter, right? The ball's velocity is decreased. Of course, whenever you uh, throw it up, the ball's velocity is decreased because you throw it with maximum velocity. I told you about the shooting bullet in previous case that I told you. Whenever you shoot, someone shoots a bullet vertically upward, the bullet is actually shooted with what? With maximum velocity. When the bullet comes down, when the bullet retreats and strikes the earth, actually it gets the same value. The velocity of the bullet when it lands on earth is as the velocity of the bullet when it's uh, actually shooted, right? That's why uh, whenever the object moves upward, the velocity is decreased, but whenever it moves down, the velocity is increased. When the object strikes the same position, it takes the same velocity, right? So in the case of ball, when the ball is moving up, the velocity is decreased. We know this information. Velocity becomes zero at maximum altitude, at maximum peak, at the peak actually. At the peak, at maximum height, at maximum altitude, velocity becomes zero. The ball stops for a while. Velocity is increased in negative direction. So, in the case of retreat, when the object is retreating, uh, velocity is increased, but in negative direction, down the actually downward. This is the part A. Part B, it says, what is its velocity when it reaches its maximum altitude? I'm sure you know the answer better than me. Without thinking, I'm sure you guessed the answer. Uh, the answer is what is the velocity when it reaches its maximum altitude? That's it, right? It's zero. The ball's velocity is decreased, right? Actually, it describes it, it elaborates it. Velocity becomes zero at maximum altitude. Velocity is increased in. So actually, I think I repeated the same answer. Uh, I'm gonna choose the part that is dedicated for the question. It's the same question. I just repeated actually the answer. Let me choose this one. We don't need this part. Uh, we don't need this part. So only the middle part of the question is true, right? Only this one. Velocity becomes zero at maximum altitude. That's it. This is the answer. Velocity becomes zero. This one. Right. Let's move on to question number 27. I'm gonna, yeah, excuse me. We have one more part for this question. Part C, it says, what is its acceleration when it reaches its maximum height? I'm sure you know the answer. What happens to the acceleration of free fall object whenever they reach a maximum altitude and it stops for a while? And I told you in previous lessons that the acceleration does not change whether the object, whether the free fall object actually stops for a while throughout the air, or whether it moves up or goes down. It doesn't matter. Acceleration remains as it is. Even the sign of acceleration is negative as well. It doesn't change. The sign of acceleration is negative actually forever, and is equal to negative 9.81 meter per second squared, even for the stopping ball uh, in air. What is its acceleration just before it hits the ground? Same thing. Acceleration is equal to negative 9.8 meter per second squared. Uh, so the answer of C and D is the same. What do you say about the E? Think about the E. Let me read it for you. Does its acceleration increase, decrease, or remain constant? Uh, I'm sure you know the answer. I told you actually uh, a minute ago. I told you that the acceleration does not change. Acceleration due to gravity, I mean. Free fall acceleration does not change. Even its sign is negative forever. That's why acceleration remains constant without changing. Right. Let's move on to another question, which is question number 27. So the figure in the right, the figure at right, this figure is a strobe photograph of two falling balls released simultaneously. Two balls released simultaneously at the same time. We have a note here. This motion does not take place in a vacuum. So this motion does not occur in a vacuum, means there is a resistance. So a resistance is existed. A resistance is present because it says the experiment or motion does not take place in vacuum, means there is air. Right. The ball on the left side is solid. The ball is solid on the left side. And the ball on the right side is hollow table tennis ball. Analyze the motion of both balls in terms of velocity and acceleration. And I'm gonna tell you this one. You have to interpret the phenomenon. You have to interpret the motions of each ball. Actually, and especially I want you to concentrate on two factors. They are very important. What are these? Velocity and acceleration. Let me read the answer and I'll break it down for you. It says, the answer of teacher's book, both balls are speeding up because they go down. Gravity pulls them down. That's why they are spinning up or accelerating. They start with approximately the same acceleration, but the smaller ball's acceleration gradually decreases because of air resistance. Right. So, uh, because the shapes of the objects actually are different. That's why air resistance for either object actually differs as well. Air resistance for the uh, smaller ball, because of its volume, actually because of its size, air resistance for the table tennis ball is very low compared to the air resistance for the actually uh, for the solid ball. That's why uh, actually the air resistance for the solid ball uh, is uh, is nothing. Air cannot resist the solid ball. For example, think about for example, marble. Think about a marble versus a table tennis ball. These marble and table tennis ball actually are moving down. They accelerate no problem. But the solid one, I mean the marble, strikes the ground, let's say before the table tennis ball, not because of their masses, because of the air resistance actually exerted on each ball. Uh, and I can say, in brief, I can say the table tennis ball exposed to what? Exposed to the higher air resistance than the actually than the solid ball, than the marble, right? I'm gonna uh, actually do it for you in next lesson because I forgot to bring the marble and table tennis here because physics is a practical knowledge. It's not theoretical knowledge. You have to do some experiments actually for to make sure that the information is correct, right? That's it. So keep in mind that their velocities their velocities are increased. They are speeding up, no problem. But the acceleration of the acceleration of the table tennis ball is greater than the acceleration of the acceleration of the solid ball. Acceleration of the solid ball, I told you, like marble, like ball bearing. Think about ball bearing. Think about even bowling ball. They are all solid. Think about a bowling ball versus table tennis ball. Whenever you actually move them down, table tennis ball actually is exposed to the what? Is exposed to the higher air resistance. That's why it lags behind the marble. The table tennis ball lags behind the actually bowling ball. Right? Keep in mind that this phenomenon actually is taking place in air, right? Whenever you evacuate uh, whenever you evacuate the room, whenever you have a room free of air, actually, even table tennis ball and a bowling ball move with the same rate at the same time. They get the same acceleration, right? And keep in mind that I'm gonna repeat it for you. Keep in mind that the change in velocity of the solid ball and the hollow ball, right? Change in velocity does not refer to their masses, right? It refers to the air resistance based on Galileo's theory. That's it, right? That's it. Let's move on to question number 28. It says a juggler throws a ball into the air with an initial velocity vi. Another juggler drops a ball at the same instant. Compare the accelerations of the two balls while they are in air. A juggler throws a ball into the air. Right. He throws the ball into the air with an initial velocity of vi. Another juggler drops a ball at the same instant, at the same time. Compare the accelerations of the two balls actually while they are in the air. So, uh, what do you get from this, for example, from this question, from this example? I throw a marker and you throw a marker, right? What happens to the acceleration of either marker, right? What happens to the acceleration of each marker actually? Two balls, actually, the two balls have the same acceleration, which is equal to negative 9.81 meter per second squared. That's it. Let's move on to question number 20, 29, right? 29. It says a bouquet is thrown upward, right? We study the motion of the bouquet in a given time interval. A, will the value for the bouquet's displacement be the same no matter where you place the origin of the coordinate system? So a bouquet is thrown upward, right? Like the bomb. A bouquet is a bunch of flower, right? Flower bunch is thrown upward. We study the motion of the bouquet in a given time interval, right? Will the value for the bouquet's displacement, let me underline the displacement for you. You have to mention the most important part. It talks about bouquet's displacement. Will the value for the bouquet's displacement be the same no matter where you place the origin of the coordinate system? Actually, bouquet's displacement, value for the bouquet's displacement uh, remains actually remains as it is. Uh, yeah, it remains as it is because whenever you change the coordinate system or not, whether you change it or not, whether you rotate it or not, it doesn't matter. So the displacement becomes constant because the motion is important, not the coordinate system. Because coordinate system is a conventional actually system. We don't have this system in reality. This is conventional. We made this actually. Mathematicians made this. For example, uh, we have Cartesian coordinate system. René Descartes actually made this or drew it. So the changing of coordinate system does not affect the displacement of the bouquet and it remains as it is. Right. Will the value for the bouquet's velocity be the same no matter where you place the origin? Yes, it doesn't matter. Because I told you they are conventional. Human made these actually these measurements. Human made these systems actually. C, will the value for the bouquet's acceleration be the same no matter where you place the origin? Yes, it doesn't matter. It doesn't change. And the last question, I'm gonna solve it for you in this lesson. It's a problem. And after this question, I finished the lesson, God willing, and I appreciate you for being with us till now. And I joined you, uh, you, and I hope you enjoyed my explanation. The 30 question number 30, it says a worker drops a wrench from the top of a tower 80 meters tall. A worker drops a wrench, right, from a high building, for example. Let me draw it for you. I'm going to draw it. There is a building, right? There's a building, and on the building, on the top of the building, a wrench, right, is dropped by a worker. a wrench is dropped by a worker, and the height of the building is 80 meters. Right. It says what is the velocity when the wrench strikes the ground? So we look for final velocity. And by the way, you have to actually you have to uh, guess the initial velocity for the wrench, which is equal to 0, even if it doesn't mention it actually, right? Whether it mentions it or not, you have to take it out from the question. You have to understand it from the meaning of the question. So a wrench is thrown actually downward. What does it mean? It means the motion starts from 0, from rest. Right. So we look for the velocity of the wrench when it lands on Earth, when it reaches the ground. Right. Uh, what's another information? We have G exertion due to gravity, which is equal to 9.81 meter per second squared. So are these information enough for finding final velocity? Yes. All right. Think about a case. Think about a rule among the kinematic equations with no time interval. So only this one, this choice is appropriate. Vf squared is equal to V initial squared plus 2g delta y. Yeah. So we have, and by the way, I told you that the height, whenever you want to solve a problem regarding the actually the free fall, you have to let's say put a negative sign in front of two things. Negative sign for displacement, negative for acceleration. So any question has to do with free fall have what? Any question has to do with free fall has negative displacement and negative acceleration, right? That's why I put the negative sign here, right? Like this. I'm gonna add it here. So V final squared is equal to V initial squared plus 2g delta y. V final squared is equal to 0 squared plus 2. In place of g, you have to substitute negative 9.81. Instead of delta y, you have to write negative 80. And the answer after calculation, you have this value. Vf squared is equal to 1569.6. In order to actually to have Vf only, right? You have to take a square root for the answer, and the answer has positive and negative part, positive and negative signs actually. I want you to guess actually guess the sign, which sign works here, negative or positive. Actually, after you take a square root, the answer will be positive and negative 39.6 meter per second. And the answer is going to be negative. Why the answer is going to be negative? Because if you think about the let's say case, whenever the worker throws a wrench downward, the acceleration throughout the motion is acceleration is negative, no problem. We have no problem about acceleration. We don't discuss about acceleration, but I'm gonna talk about velocity. Velocity of the wrench throughout its motion is negative because it's moving down. Thank you very much, guys, for watching this video, and bye for now.